atoms. In this case of in intermediate second year physics, we have the unit number is 13, that is atoms. So in that atomic theory of matter was first proposed by Dalton. The Dalton proposed that his theory, atomic theory about the atoms. Atom is an indivisible particle which cannot be divided. The atom, which is having the smallest particle in the universe, he has given this idea. And after that Dalton, some of the scientists have given idea about the atomic theory. Now after the Dalton's, J.J. Thomson gave an idea about that atoms, that smallest particle atom can be divided into the small particles like called electrons, protons and neutrons, that can be divisible. So that in the case of the, according to the Thomson's atomic model, he has given some of the postulates, some of the ideas about that atoms, the structure of the atoms, then the positive and negative charge, how that adjusted in the atom, means how that is a uniform distributed the charge in the atom. So he has given some of the idea according to this model, according to the Thomson's model of an atom. In that case of the positive charge of an atom is uniformly distributed over the atom, and the negative charged particles called electrons are situated at equally to adjust the static electronic force to fix that, so that the atom possesses its spherical shape and the total positive charge is uniformly distributed all over the atom, and negative charged electrons are placed which is the seeds are placed in the watermelon, like equally the negative charge of electrons are embedded in such a manner. So in this model can be visualized as a pudding or a watermelon of a positive charge with plums and seeds embedded into it. So this model is called as a plum pudding model or a watermelon model. In this case of, when the J.J. Thomson has given an idea about that atom, structure of an atom which is having the spherical shape, approximately its diameter is a radius about 10 to the power of minus 10 meter. Then here the total radius is about 10 to the power of minus 10 meters of the total shape of which is having the spherical shape of an atom. The positive charge is placed all over the uniformly distributed in the atom, and the negative charged particles are embedded in the atom. So that in this case of the stability of an atom, he could not explain about the stability of an atom, and as well as whenever the alpha particle is entered, means incident on that atoms, then that alpha particle scattering experiment is not explained by this model or by the Thomson's model of an atom. So that the drawbacks of the J.J. Thomson's model of an atom is he could not explain about the stability of an atom, and as well as he could not explain about the alpha particles scattering experiment. So that we can say that the atom possesses spherical shape about to radius 10 to the power of approximately 10 to the power of minus 10 meters, and which has a positive charge uniformly distributed throughout the volume of the atom, total throughout the volume of the atom, and as well as the negative charge electrons are embedded in such a manner, the electrons are embedded, and as well as this model can be visualized as a pudding or a watermelon with plums or seeds. So that its model is also called as a plum pudding model or watermelon model. The drawbacks of the J.J. Thomson's atomic model is it could not explain the alpha particle scattering experiment, and as well as it could not give an explanation about did not give any explanation about the stability of an atom. The further experiments after the J.J. Thomson, the former student of the J.J. Thomson, that is Ernest Rutherford. Ernest Rutherford has given that the gold foil method, means alpha particle scattering method. According to the Ernest Rutherford, give the Ernest Rutherford given alpha particles scattering experiment. Did the alpha particle scattering experiments. That is the former student of the J.J. Thomson. So, in that case, the Ernest Rutherford did the alpha particles scattering experiment by his students, that is Geiger and Marsden did the experiment about that by using the gold foil, thin film of gold foil like this. The experiment is called alpha particles scattering experiment, also called as Geiger-Marsden experiments. In this case, now we are taking that the source of an alpha particles which is emitted by the bismuth. The bismuth we are using as a source of an alpha particles, and we are making with the lead bricks, it's a slit, it is called as a collimator. So, whenever the bismuth is emitted, the alpha particles through the radioactive source were collimated into this, then through the narrow beam traveled is a beam of alpha particles. It's a beam of alpha particles are incident in the gold foil, thin gold foil. Okay, so this is called as collimator. Due to the help of the collimator, the narrow beam is incident on the gold foil, and it is having the thickness of approximately it is 2.7 into 10 to the power of -7 meters. This is about the thickness of this gold foil. This is about the thickness of the gold foil. So, whenever the beam of alpha particles are passing through the collimator and incident on the gold foil, the alpha particles are scattered into the different directions. Alpha particles are scattering into some of the particles are reflected like this, and some of the particles are moving from this, and some of the particles are reflected and moving into the scattered into the different directions. Whenever throughout the different angles were observed through the rotate detector, that scattering particles we can observe by using the detector which is on the rotatable detector on the ZNS screen, means a zinc sulfide screen. It is having the zinc sulfide screen which is connected with the microscope and detector, which is the rotatable detector. We can observe the scattering alpha particles with different directions, with making an angle, different angles. The scattering alpha particles produce bright fringes or flashes or scintillations on the ZNS screen. Means whenever the beam of alpha particles incident on the gold foil and the total alpha particles will scatter into the different directions. Whenever they are scattered into the different directions, whenever it is incident, we can observe by using the detector which is fixed on the ZNS screen with microscope. And the alpha particles whenever incident on the ZNS screen can give the flashes or scintillations on the ZNS screen. So, whenever this is the actual path has to move by the alpha particles, but the particles are scattered with some of the angles with the initial particles, means with initial actual original path. So that here we can say that the angle of theta of deviation of an alpha particle, means the angle of theta of an deviation of an alpha particle from its original place, original direction. So that the theta is called as a angle of scattering. The deviation theta means the angle of theta of deviation of an alpha particle from original direction is called as, this is angle of scattering, means the alpha particle has scattered with an angle theta. So that's why the angle is making an angle with the original direction can be said as the angle of scattering. So that by the angle of scattering we can say that the angle of theta deviation of an alpha particle from its original path is called as it's angle of scattering. So we can observe that here not all the particles are scattered, not all the particles are travelled through the gold foil, and not all the particles are scattered. Some of the particle has moved slightly and incident on the ZNS screen, and some of the particles are reflected and some of the particles are scattered. So that here we can say that whenever the particles, means the alpha particles passes straightly through the gold foil, does not affected by any collisions, does not suffered any collisions, so with gold atoms, but only up to 0.14% of the alpha particles are scattered more than 1 degree centigrade, more than 1 degree angle, means more than 1 degree angle, the 0.14 of the alpha particles are scattered. That means say about to 1 in 8000 alpha particles. In 8000 alpha particles, that one particle has scattered more than 90 degrees. Here, which is having that, whenever the light rays is traveling like this, then the light is scattered with an angle of 90 degrees in 1 in 8000. 1 in 8000. 1 in 8000, and also some of the particles are making a theta is equal to 1 degree angle by making an effect. 0.14% of the alpha particles are scattered, which is up to 1 degrees angle, and more than the 90 degrees angle scattered by this 1 alpha particle in 8000 alpha particles. So that these are the observations by the gold foiling experiments, means this is done by the Geiger-Marsden experiments, and in case of whenever, so this is about the explanation and about the observations. Once again, a stream of 5.5 mega electron volt, its energy, the 5.5 mega electron volts alpha particles emitted from a source of the bismuth radiated source were collimated into the lead bricks, means a narrow beam of with the help of the lead slit. This is the lead slit, and a beam of alpha particles incident on the gold foil, so that the collimated beam is allowed to fall on a thin gold foil of thickness, that is 2.1 into 10 to the power of minus 7, means 2.1 into 10 to the power of minus 7 meters will be the thickness of the gold foil. As well as here alpha particles are scattered in different directions, means whenever the alpha particles are incident on the gold foil, then the light rays, means alpha particles is scattered into the all direction different, with making an angle different by the original direction. The angle made by the scattered particles, the angle made by the scattered alpha particles with the original direction of the alpha particles is called as angle of scattering. Means the angle made by the scattered alpha particles with the original direction of the alpha particles is called as angle of scattering. Means whenever this is the original path of the alpha particles has to move in this direction, but whenever incident on the gold foil, the angle incidented by the means the light rays alpha particles scattered in this direction with making an angle of theta with the original direction. So that's why we can say that theta be the angle of scattering, so that the scattered alpha particles produce bright flashes, and this will be the ZNS screen, zinc sulfide screen. Whenever the scattered is incident on this ZNS screen, that will flashes and scintillations on the ZNS screen will be happen. The angle of theta means the angle of scattering, the angle of theta of deviation, means the deviated angle is making an angle theta with the original direction of the alpha particle. So that's why the angle theta of deviation of an alpha particle from its original direction is called the angle of scattering. So we can observe some of the things by this experiment is when the alpha particles passes straight through the gold foil, do not suffer any collisions with gold atoms. Means we know that the alpha particles are the positive charged particles, means which is having that we can get converted that the positive charge of an helium atom is considered as alpha particles, means positive charge of an helium atom is considered as alpha particles, so that whenever they are incident on the gold foil, only we know that the like charges can repulse and unlike charges can be attracts. Whenever the positive charge is in the gold foil at the center instant, that the light ray is reflected into the same direction. Otherwise whenever they collide with the gold foil atoms, so they, by the collision of the gold foil atoms with the same charge, they can scatter into some of the direction because of the repulsion. So that we can say that here the collimated beam means whenever the scattered alpha particles produce scintillations, after that the angle of alpha particles passes straight without any suffer of collision, then we can say that they are allowing the positive charge allowed through the gold foil without any collision, means they are having the negative charge at their places. If in case of, if they suffer any collision with that, then same like charges is held on that place. So that we can say that only about 0.14 alpha particles, incident alpha particles scattered by the more than 1 degrees, by more than 1 degree. And here the one alpha particle in 8000, one of about 1 in 8,000, 1 in 8,000 scattered by more than the 90 degrees. More than the 90 degrees means whenever they are reflected, means it is moving into the same medium, whenever it is traveling into the same medium, it is reflected into the same medium. More than 90 degrees means that will be reflected. Due to the reflection means whenever the gold foil alpha particle is incident on the gold foil, whenever the positive charge is placed at that gold foil is there, then due to the repulsion between them, that can be reflected. Okay, so that is about the Geiger-Madsen experiment and the observations.